Hello students, in this video we will be starting the division of integers. In the previous video we talked about exercise 1.3. In this video let us continue with the lesson integers. So let us start with the division of integers. We know that division is the inverse operation of multiplication. So just how addition and subtraction are inverse operations of each other, division and multiplication are also inverse operations of each other. Let us see an example for whole numbers. Since 3 times 5 is equal to 15, so 3 5s are 15. So 15 divided by 5 is equal to 3 and 15 divided by 3 is equal to 5. Okay, so because division is the inverse operation of multiplication, we have the product here of 3 and 5 equal to 15. So whenever we divide 15 by either the multiplicand or the multiplier, we get the other factor as the answer. So let us recall what multiplicand and multiplier are. In a product, the first number is called as the multiplicand and the second number is called as the multiplier. So because product of integers is commutative in nature, it is not exactly necessary for you to remember which is the multiplicand and which is the multiplier, but just keep in mind that both of them are factors of the product. So whenever we can multiply one number with another to get a different number, it is said that those two numbers are the factors of the product. Coming back to our example here we had 3 and 5 to be factors of 15. So whenever we divide 15 by either 3 or 5, we get the other factor as the answer. Similarly, when we multiply 4 and 3, we have 12. Therefore, 12 divided by 4 is equal to 3 and 12 divided by 3 is equal to 4. This is for whole numbers. We can say for each multiplication statement of whole numbers, there are two division statements. So for each of the factor, it can become the divisor and we will get the other factor as the quotient. Again, let's just recall what dividend, divisor and quotient are. Given a division operation, the number that you're dividing becomes the dividend and the factor by which you're dividing that number becomes the divisor. And the result is called as the quotient. So given a product like we are seeing here, given a product of 4 and 3, either 4 can become the divisor or 3 can become the divisor. In either of the case, the other one becomes the quotient. Okay? So for every multiplication statement, we can say that we have two division statements. Can you write the multiplication statement and its corresponding division statements for integers? Observe the following and complete it. So here we have the list of multiplication statements, and from each multiplication statement we can have two division statements where either of the factors are becoming the divisor. Okay? So for example, in the first multiplication statement, we had 2 into minus 6 is equal to minus 12. In the first one, we had minus 6 becoming the divisor, whereas in the second, we have the number 2 becoming the divisor. Similarly, we have to write it for the others. I'll just complete one of these so that you can complete the rest of them. Here we have minus 8 into minus 9 is equal to 72. Therefore, we can write it as 72 divided by, you can either take minus 8 or minus 9 first. Let us take minus 8 first. This is going to give us the other factor, that is minus 9. Similarly, you can then take minus 9 to be the divisor and you will get minus 8 as the answer. Remember, these are just terms that we have given to the individual terms in a division statement. This is the dividend, divisor and quotient. Okay? Similarly, you can answer the rest of the questions given here. Let us move on. From the above, we observe that Minus 12 divided by 2 is equal to minus 6. Minus 20 divided by 5 is equal to minus 4. Minus 32 divided by 4 is equal to minus 8. Minus 45 divided by 5 is equal to minus 9. So if you make a keen observation here, not only did we write two division statements from each multiplication statement, we also found out the signs of the quotients after we divide it by either a positive or a negative number. Take the first example. Here, the product was minus 12, okay? And if you divide it by minus 6, the answer was 2. Why is this? This is because we know that the product of minus 6 and 2 only gives us minus 12. There is no other integer with which we can multiply minus 6 to get minus 12. Okay? So this means that when you divide minus 12 by minus 6, you have to get 2. Similarly, when you divide minus 12 by 2, you have to get minus 6. So here we are observing a pattern, that is, whenever we are dividing a negative integer by a negative integer, the answer is positive. Whereas whenever we are dividing a negative integer by the positive integer, the answer is negative. Similarly, we have a generalized statement here. We observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a negative sign before the quotient. Okay? So whenever we are dividing a negative integer by a positive integer, like in this case, we divide them as whole numbers and keep the negative sign before the quotient. Also, whenever we are trying to divide a positive integer by a negative integer, it is also the same case. Okay? So when we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. So in general, for any two positive integers a and b, a divided by minus b is equal to minus a divided by b. Okay? So observe here that we have a restriction. B cannot be equal to 0. This is because division by 0 is not defined. The answer will not be an integer. It will not be a number at all. Okay? So here we have a restriction here. For this general case, a divided by minus b is equal to minus a divided by b, and the answer is going to be negative if a and b are both positive. Okay? So what we saw here was division between alternating signs, that is whether you divide a positive number by a negative number or whether you divide a negative number by a positive number, we will be getting a negative number. Now let us go on to try these exercises. So the first one is 125 divided by minus 25. We saw that whenever we are trying to divide a positive integer by a negative integer, we need to consider them as whole numbers and then we need to add the negative sign. So we know that 125 divided by 25 is going to give us 5. Okay? So 125 divided by 25 is going to give us 5, and then because 25 is negative and 125 is positive, we need to add the negative sign. The answer to A is minus 5. Similarly, you can carry out these two problems. Lastly, we observe that minus 12 divided by minus 6 is equal to 2. Let us consider this particular equation for a minute. I'll write it over here so it's easier for all of you to see. So we saw that minus 12 divided by, I'm just going to use this symbol to indicate divided by. It's common to use this symbol also. Okay. So minus 12 divided by minus 6 is equal to 2. So how do we know this is true? It's because if you take this 6 to the right hand side, that is if you try to find out the corresponding multiplication equation to this division, how do we do it is, we can just say that this implies minus 6 into 2 is going to be equal to minus 12. So we know that minus 6 into 2 is going to be equal to minus 12. This is because negative into positive is equal to negative. We have learned this in the integer multiplication. Okay? Because this is the corresponding multiplication equation for the above division equation, we know that minus 12 divided by minus 6 should give us the other factor. The other factor here is 2. Okay, so that is how we know minus 12 divided by minus 6 is equal to 2. Similarly, if we consider the other equations, we have minus 20 divided by minus 5 is equal to 5, minus 32 divided by minus 8 is equal to 4, and minus 45 divided by 9 is equal to 5. Divided by minus 9 is equal to plus 5. So, we can say that when we divide a negative integer by a negative integer, we first divide them as whole numbers and then put a positive sign. Okay? Whenever we are dividing two negative integers, we have to divide them as whole numbers and then put a positive sign. So this is somewhat easy for you to remember because we saw that in the multiplication of negative numbers, negative into negative would give us positive. Similarly, negative divided by negative is also equal to positive. So in general, for any two positive integers a and b, minus a divided by minus b is equal to a divided by b. Okay, so this is just saying divide them as whole numbers and keep the positive sign as it is. Also observe that this is very important that you explicitly present this restriction where you say that where b should not be equal to 0, because once b is equal to 0, anything divided by 0 is not defined. Okay. Next, the next set of try these exercises. Here we have find that minus 36 divided by minus 4. So minus 36 divided by minus 4, we just saw that we need to divide them as whole numbers and then keep the positive sign. So 36 divided by 4 is going to give us, that's right, 9. Okay, so 36 divided by 4 is equal to 9 and then we need to keep the positive sign. Similarly, you can attempt the B and C problems. Next, let us talk about the properties of division of integers. So in the previous videos, we covered the properties of multiplication of integers. Similarly, let us look into the properties of division. Observe the following table and complete it. What do you observe? We observe that integers are not closed under division. So let's see how we came to that conclusion. Here we have the first statement, minus 8 divided by minus 4 is equal to 2. So we just learned in the previous section that negative by negative is equal to positive. That is why the answer is plus 2, and as we can see, plus 2 is an integer. However, if we switch the places of 4 and 8, we get minus 4 divided by minus 8. And the answer is going to be a fraction. Okay, so this result is not an integer. Okay, whenever we are saying something of a property, you just need one example to disprove that property and we know that it doesn't hold that property. Okay, so here we found an example of division of integers where you divide one integer by another but the result is not an integer but a fraction. This means that integers are not closed under division. Similarly, we have a couple of more examples here. Here we have minus 8 divided by 3. 3 is not a factor of 8. That means there is no integer with which you can multiply 3 to get 8. So this is going to become a fraction or a decimal. Okay. So similarly, so is 3 by minus 8. This is also not equal to an integer. So all these are just examples that support this evidence that integers are not closed under division. We can justify it by taking 5 more examples of your own. So we also know that division is not commutative for whole numbers. Let us check for integers also. Let me remind you that integers consist of whole numbers and negative integers. Okay. So in the number line, everything to 0 and its right, it's whole numbers, and everything to the left of 0, excluding 0, they are the negative numbers. Okay. So whenever we are saying that whole numbers does not have a property, then that directly implies that integers does not have that property either. This is because we know that whole numbers is the subset of integers. Okay. So if you consider this as the set of integers, then whole numbers is just a subset in it. Okay. So this can be the set of whole numbers. But technically both integers and whole numbers are both infinite sets, and whole numbers take exactly half of the set of integers because we have positive integers and 0 together and negative integers that are forming the rest of the set of integers outside whole numbers. Okay, so this is just a representation so you understand what I mean when I say whenever you have to say that a property holds, then it has to satisfy everything that is inside this pink circle. Okay, this pink circle right now represents the set of integers, and this yellow circle, let us assume that it represents the set of whole numbers. Okay, so whenever you're saying that a property holds for the entire set of integers, then it has to hold for the set of whole numbers. So if you know that some property does not hold for the set of whole numbers, then you can directly say that it cannot hold for the set of integers, because if that were true, then it should have held for whole numbers also. But we can also check with more integers. Let us check if division is commutative for integers. So taking the same example as the previous case where we saw that integers are not closed under division, you can see that minus 8 divided by, let me take a square. Yeah, minus 8 divided by 4 is not equal to minus 4 divided by minus 8. Okay, so if you just switch the places of the divisor and the dividend, the quotient is not going to remain the same. Similarly, we have more examples that are shown to us over here. From this example, we can say that division is not commutative for integers. Okay, and as usual, you can take 5 more pairs of integers to verify this property. Like whole numbers, any integer divided by 0 is meaningless, and 0 divided by any integer other than 0 is equal to 0. Okay, so we used to see this property where whenever we are generalizing anything, we always have to say where b not equal to 0, where the dividend is not equal to 0. I mean where the divisor is not equal to 0. So this is the dividend, this is the divisor, and this is the quotient. Okay, so we cannot have the divisor to be equal to 0. So for any integer, division by 0 is meaningless. When you learn about the bigger sets of numbers and their properties, perhaps this rule will become more understandable to you. For now, just keep in mind that you cannot divide anything by 0 meaningfully. For any integer a divided by 0 is not defined, but 0 divided by a is equal to 0. Observe here that a is becoming the divisor. Therefore, we need to state that a not equal to 0 explicitly. Okay. Next, when we divide a whole number by 1, it gives the same whole number. Okay. So we have learned in the previous classes about whole numbers that whenever there is a division by 1 that is happening, then it gives us the same number. So for you to get an intuition about it, just think of it this way. Division by 1 is the same as having to divide it and give the whole thing to just one person. Okay. So you can assume that division by 2 is whenever you have a quantity of things with you and you have to divide it equally among 2 people, that is division by 2. But division by 1 is there's just one person and you have to give it entirely to that person. That means that you just give it all. Okay. So this is true only for natural numbers, that is only for counting numbers. Uh, by this I mean the intuitive understanding behind it, but the property holds for the bigger sets of numbers, including whole numbers and integers. Okay, so when we divide a whole number by 1, it gives the same whole number. Let us check whether this is true for negative integers also. Here we have minus 8 divided by 1 is equal to minus 8. Using the properties that we have learned in the previous sections, if we solve all of these, we get that whenever a number is being divided by, whenever an integer in particular is being divided by 1, you get the same integer. Okay? Therefore, in general, we can say that any integer divided by 1 gives the same integer. A divided by 1 is equal to A. Now, let us look into what happens when we divide an integer by negative 1. So, what is going to happen when we divide an integer by minus 1? Keep in mind the rules of division that we just learned and look at the first question. Minus 8 divided by minus 1. So, here we are dividing two negative integers. This means that the answer is going to be positive after dividing them like whole numbers. So 8 divided by 1 is 8. Because they are both negative, it is plus 8. Okay. Similarly, if we divide plus 11 by minus 1, we have to divide them like whole numbers and keep the negative sign because the dividend, that is 11, is positive and the divisor, that is 1, is negative. Okay. So if you solve all these examples, you can observe that if any integer is divided by 0, it does not give the same integer. Okay. Actually, to come to this conclusion, you can just give one example. This is by saying proof by counterexample. Okay. You will learn more about how you can prove properties in your higher classes, but giving one counterexample is sufficient to disprove a property. So here the property or the claim in question was, does division by minus 1 also have the same property as division by plus 1? The answer is no, because we have so many examples here where division with minus 1 is giving us a different integer. In particular, it gives us the same integer with the sign flipped, or its additive inverse. Okay. So division by minus 1 does not give us the same integer. Note that you have to be a little careful whenever you're using division by 1 because it's quite easy to read a question wrong. In this case, is 1 divided by a equal to 1? Think about this a little bit before you play and get the solution. So here you can take any example. A is equal to 3. Okay, just say A is equal to 3 and 1 divided by A is 1 by 3. This is not equal to 1. Okay, so I've just written it like this to say not equal to. Okay, so 1 divided by 3 is not equal to 1. However, if it were opposite, that is if A divided by 1, then that is true. A divided by 1 is always equal to A, not 1. Okay. Next, A divided by minus 1 is equal to minus A. For any integer A, is this true? The answer is yes. This is true for any integer A except 0. Even in case of 0, you can take negative of 0 to be equal to 0 itself because negative 0 does not have any meaning. So this is true for any integer. Okay. Move on, and here we have an example that is going to say that division is not associative for integers. Minus 16 divided by 4, the whole thing divided by minus 2. Do you think this is equal to minus 16 divided by 4 divided by minus 2? Let us solve this one by one. Okay. So here we have the right hand side. We will solve the left hand side first. So this is the left hand side of the potential equation. Okay, so we want to say if this is equal to this. So let us make this the left hand side. Solving the left hand side first, we need to solve this grouping. Okay, so this grouping, by the rules of division, we get the answer to be minus 4. And copy the minus 2 as it is. And minus 4 divided by minus 2 is equal to plus 2. Okay. Next we have minus 16 divided by 4 divided by minus 2. Here we have to solve this part first. 4 divided by minus 2 is going to give us minus 2. And copy the minus 16 exactly as it is. And we will find that the answer is 8. So 2 is not equal to 8. So right hand side and left hand side are not equal. We can say that division is not associative for integers. So as we can see here, most of the rules, including the commutative associative rule, they do not hold for division of integers. Okay. Next, we will be starting with example 6. Okay. I'll just take you through it very briefly, and in the next video we can start with the next exercise 1.4. Example 6, let us look at the question. In a test, plus 5 marks are given to every correct answer and minus 2 marks are given to every incorrect answer. Radhika answered all the questions and scored 30 marks, though she got 10 correct answers. Okay, so here we have the data. Next, we have the second question. Before we go to the second question, let us solve question 1. So the question here is, how many incorrect answers had they attempted? The way we solve this is, we need to write down the data that has been given in the statements clearly. So the first data that has been given is, marks given for one correct answer is equal to 5. Okay. And they are already writing this inference, but before you write that down, you can also write down all the data once and then move on to making inferences. Okay. So marks given for 10 correct answers is equal to 50. How do we know that there were 10 correct answers? It has been given in the question. So Radhika got 10 answers correct. So the marks is 50. However, she has scored only 30. What is the difference? The marks that has been obtained for the incorrect answer is the difference. And that is equal to minus 20. So the total score after deducting the marks that has to be deducted for negative marking minus the initial score after calculating only for positive marking is going to give us minus 20. The difference is minus 20. This means that in order for us to find out how many questions she got it correct, we have to divide it by how many marks is deducted for each incorrect answer. So from the data we have, marks given for one incorrect answer is equal to minus 2. Therefore, the number of incorrect answers is going to be the total marks that has been deducted divided by marks for each question. Observe that the multiplication equivalent of this would have been if that person got 10 answers incorrect and if minus 2 is the marks deducted for each incorrect answer, the total marks that would have been deducted would have been equal to 10 into minus 2. Okay. So here the answer is minus 20 divided by minus 2, that is equal to positive 10. Observe here that because the question is find the number of incorrect answers, it has to be a whole number. Negative number of incorrect answers does not have any meaning because you can't count using negative numbers. Okay. Next, similarly, you can look through the marks that has been given for J's correct answers and you can find the number of incorrect answers attempted by J. Let us just go through the example 7. A shopkeeper earns a profit of ₹1 by selling one pen and incurs a loss of 40 paisa per pencil by selling pencils of her old stock. Okay, so this shopkeeper, she earns a profit of 1 rupee by selling one pen, and she loses 40 paisa per pencil while selling pencils of her old stock. In a particular month, she incurs a loss of rupee 5. In this period, she sold 45 pencils. How many 45 pens? How many pencils did she sell? Okay. So before you go through the solution, just think about the plan that you have to solve this problem. Think about it stepwise. What we know is that she sold 45 pens. So we should be able to calculate the amount of money that she has gained by selling 45 pens. Because we know that she earns a profit of 1 rupee per pen. Okay? And in that particular month, it is also said that the total loss is rupee 5. That means that the difference that is between 5 and 45 is the loss that she has incurred by selling pencils at the loss of 40 paisa per pencil. So you can see here that that is how they have given the solution also. Here we have the loss is equal to minus 50 rupees. Okay. This means that we have to convert this rupees into paisa. We know that 1 rupee equal to 100 paisa. So this is 5000 paisa. And we know that per pencil she has a loss of 40 paisa. So how many pencils has she sold is 5000 by 40. And the answer is going to be 125. Similarly, you can try the next one where the total loss or profit is equal to 0, and you have to calculate how many pencils she has sold. One hint that I can give you, one advice I can give you is, before you go through the solution of the solved examples, attempt it yourself. Only then look at the solution to check your working. This way, the exercises will become very easy for you. In the next video, we will solve exercise 1.4. I will see you all in the next video.